All right, so let's look at the first example from this sheet. We have f of x equals x plus 2 if x is less than or equal to negative 2, and f of x equals 3x if x is greater than negative 2. So what I want to do, as we talked about in class, anytime we deal with a piecewise function, we really want to start by looking at what's going on when it shifts from the one function to the other. And for this one, that happens when x is negative 2. So what I'm going to do is I'm going to look and see if I were to plug in negative 2 into both of the two function rules, where would my output, or my f of x, be? So for the first function, when x is negative 2, y is 0. So I'm going to actually plot a point at negative 2, 0. And in fact, that point's going to be a closed dot. Because for the real function, the graph is defined to be x plus 2 at this point. Now when we get to the second piece, the 3x, when x is negative 2, y is negative 6. I am also going to plot a point there. However, it's going to be an open circle. So here's negative 6, and that's going to be open. And the reason why is because our function is not defined using 3x when x is negative 2. Okay? Now I've got to just talk about what's going to go on for things bigger than negative 2 and what's going to go on for things smaller than negative 2. So for things that are smaller than negative 2, and by things I mean x coordinates, we're going to use the first rule. So I'm going to continue plotting to the left of the black dot using the equation y equals x plus 2. Now since the slope is 1, because it's 1x plus 2, remember, mx plus b, instead of going up 1 and over 1, we're going to go down 1 and over to the left 1. Down and to the left, down and to the left, down and to the left. Okay, and the reason why is because I don't care what's going on to the right of this graph. Okay? Now to look at things that are going on to the left of the blue open point, we're going to use the 3x rule. So we'll go up 3 over 1, up 3 over 1, up 3 over 1, and then we can connect those dots. Okay? As far as our domain and our range, the domain is all real numbers. Because as you look across the x-axis, we see that this graph exists for all values of x. The range is also all real numbers, because when you look up and down the y-axis, the graph exists for all values of y. Okay? Alright, so now let's look at number 2. We have h of x equals 4 minus x when x is greater than 0, and negative 2x minus 2 if x is less than 0. So again, I'm going to look starting at my 0. Okay? So when x is 0 for the first graph, y is 4. So 0, 4 is what I'm going to plot for the first function. Since it doesn't equal 0, because there's no bar, I'm going to put a dot, an open dot at 0, 4. Okay? For the next one, we'll use red. When x is 0, y is negative 2. So I will also graph an open circle at 0, negative 2. This one's a little different than some of the ones we've been doing, because x doesn't ever equal 0. So we actually are going to have two open circles. From the blue open circle to the right, we're going to keep graphing the equation y equals 4 minus x. So the slope for that one is negative 1. So we'll go down 1, over 1, down 1, over 1, etc., etc. And then we can connect all those blue dots. So this is 4 minus x. And then we can go to the red dot. And to the left of the red dot, we can graph using the slope negative 2. So we'll go down 2 over 1. Excuse me, we're actually going to go to the left side. So instead of going down 2 over 1, how about we go up 2 over 1, up 2 over 1? Because remember, the slope is negative 2 over 1. But that also, that's really hard to see in the gray. The slope is negative 2 over 1. We can also think of it as positive 2 over negative 1. So we can go up 2 and to the left negative 1 instead, which is what we did here. Okay, so if we connect those dots like that, we have the other piece. So now we need to come up with what the domain and range of this function is. So, as we look across our x-axis, it would appear that there is one x value that we don't have graphed, and it's right here at x equals 0. So our domain is the set of all x such that x does not equal 0. Okay? As far as the range goes, if we look up and down the y-axis, the red arrow gets us really big values of y because it keeps going up. The blue arrow gets us really small values of y because it keeps going down. So I think we can say that the range is all real numbers.